So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, welcome to this next problem solving video. So let us try to read out the question. In this question, a message signal is given which is a triangular shape Then this message signal is phase modulated and Kp is unknown. Carrier frequency is mentioned as 1 MHz and we are obtaining the phase modulated signal. And it is given that the maximum frequency deviation of this phase modulated signal will be 80 kHz. So we have to calculate the maximum and minimum instantaneous frequency. So we know that the general expression of phase modulated signal becomes theta I as a function of t equal to omega ct plus kp mt. So I can obtain the instantaneous frequency by differentiating it. So whenever I will differentiate the instantaneous angle, I will get the instantaneous frequency. So it will become kp dmt by dt. Now this f phi as a function of t can be written as fc plus kp upon 2 pi dmt by dt. So if I compare this expression with this fc plus delta f as a function of t, so this delta f as a function of t comes out to be kp upon 2 pi dmt by dt. So this we got it as instantaneous frequency deviation. So this is your instantaneous frequency deviation. Now what you can do, you have to calculate the maximum frequency deviation. So let me define a few more terms. First term is this minimum, so this will become kp upon 2 pi dmt by dt minimum. So we know that dmt by dt will represent the slope of this particular graph. So let us calculate the slope. Since this axis is in millisecond, so this slope can be written as plus 16 by 8 into 10 to the power minus 3. Similarly, this slope can be written as minus 16 by 2 into 10 to the power minus 3. So from here you can say that the maximum value of slope is coming out to be, this will be maximum value of slope because this is positive, so it will become 2 into 10 to the power 3. Similarly, the minimum value of the slope is coming out to be minus 8 into 10 to the power 3. So this value you can write here dmt by minimum. Similarly, this delta ft max can be written as kp upon 2 pi and it will become dmt by dt max. So these are the minimum and maximum value of frequency deviations in either direction. Now if I have to calculate maximum frequency deviation, so maximum frequency deviation, and it is defined as mod of delta ft max, or it can be written as kp upon 2 pi dmt by dt, its modulus and its max. Kp upon 2 pi is positive and constant, so I can write it as kp upon 2 pi dmt by dt mod max. So it is representing that we have to first of all take the slopes, and whichever slope magnitude is maximum, that magnitude we should take. So these three expressions are different in meaning. It is representing the maximum value of dmt by dt, it is representing the minimum value of dmt by dt, but it is representing the maximum value of modulus of dmt by dt. So we have obtained two values of dmt by dt. So the first value of dmt by dt, which was minimum, it was minus 8 into 10 to the power 3. So if I will take its mod, then it becomes 8 into 10 to the power 3. Similarly, we had dmt by dt maximum, which was 2 into 10 to the power 3, and its modulus value will become 2 into 10 to the power 3. So out of these two, you can see that after taking modulus, this value becomes maximum. So this can be written as kp upon 2 pi into 8 into 10 to the power 3. It is given in the problem as 80 kilohertz. So you can write kp upon 2 pi into 8 into 10 to the power 3. It is maximum frequency deviation, so it will become 80 into 10 to the power 3. So from here your Kp comes out to be 20 pi radians per volt. So this was the first question. In the second question, let us see what it is asking. It is asking the maximum and minimum value of instantaneous frequency. So we have already calculated the instantaneous frequency. So this instantaneous frequency becomes Fit equal to Fc plus Kp upon 2 pi dmt by dt. Fc is already mentioned in the question 1 megahertz, so you can write it as 1000 kilohertz. Now if I have to write the maximum value of instantaneous frequency, so this maximum value becomes Fc plus Kp upon 2 pi. It is constant and we have to take its maximum value. So you can write it as 1000 kilohertz. Kp we have already calculated as 20 pi, so you'll divide it by 2 pi, and the maximum value, now we are interested in its maximum value. We are not interested in the maximum value of the modulus. So its maximum value comes out to be 2 into 10 to the power 3. So it becomes 1000 kilohertz plus 20 kilohertz, or overall you can write it as 1020 kilohertz. Similarly, if I have to calculate the minimum instantaneous frequency, so the minimum instantaneous frequency becomes Fc plus Kp upon 2 pi dmt by dt minimum. So this becomes your 1000 kilohertz. Kp is again 20 pi. So this 20 pi is divided by 2 pi, and the minimum value of the slope becomes minus 8 into 10 to the power 3. So it becomes 1000 k minus 80 k, or you can write it as 920 kilohertz. So in the problem, three things were asked. First, it was asking about Kp. So Kp coming out to be 20 pi radian per volt. Second, maximum value of instantaneous frequency, it is coming out to be 1020 kilohertz. And third, the minimum value of instantaneous frequency, and it is coming out to be 920 kilohertz. So these three things were asked in this problem. Now let's move on to the next problem. In the next problem, a message signal is shown in the figure. If m of t is frequency modulated on a carrier with a frequency of 10 to the power 6 Hz with a frequency deviation constant kf, and it is equal to 5 Hz per volt, what is the maximum instantaneous frequency of the modulated signal? So in the case 1 and in the case 2 or B, it is asking that if m of t is phase modulated with phase deviation constant is 3 radians per volt, what is the maximum instantaneous frequency of the modulated signal? So from the first case, or the A part, we know that it is asking about the frequency modulation. So for frequency modulation, we already know that first of all we check Kf. So Kf is given as 5 Hz per volt. If Kf is 5 Hz per volt, so we can write the definition of Fm as Fi as a function of t equal to Fc plus Kf mt. So in this problem, it is asking about the maximum instantaneous frequency. So what will be the maximum instantaneous frequency in this case? It will become Fit max equal to Fc plus Kf mt max. In the problem, the carrier frequency is given as 10 to the power 6 Hz or it becomes 1000 kilohertz. So you can write it as 1000 K. This kf is given in the problem as 5 hertz per volt, so you can write it as 5. And what is the maximum value of message signal? So you can see here that maximum value of the message signal is 10 to the power 5. So this maximum instantaneous frequency becomes 10 to the power 6 plus 0.5 times 10 to the power 6, or you can write it as 1.5 megahertz. So the first part was very simple, and the maximum instantaneous frequency comes out to be 1.5 megahertz. Now let us see in the second problem. So in the B part, Kp is given as 3 radian per volt, and it is asking about the Pm. So we know that in case of Pm we have only one expression, which is theta it equal to omega ct plus Kp mt. So whenever you will differentiate this, d theta it by dt equal to omega c plus Kp dmt by dt, and it comes out to be the instantaneous frequency of signal. So this fit can be written as fc plus Kp upon 2 pi dmt by dt. Now you have to calculate the maximum value of this fit. So this maximum value becomes fc plus Kp upon 2 pi dmt by dt max. So we have to calculate the maximum slope of the message signal. So from here you can see that the slope of this region will become 10 to the power 5 by 1. The slope of this region becomes 0, and the slope of this region becomes minus 10 to the power 5. So you can see that the maximum possible slope that can be, it will be equal to 10 to the power 5. So you can write it as 1 into 10 to the power 6 plus value of Kp is 3 upon 2 pi, and the maximum value of slope which is coming out to be in this case is 3 by 2 pi into 0.1 into 10 to the power 6, and this can be written as 1.09 megahertz. Now let's move on to the next question. So in the next question, a periodic message signal is given as, and it is given that this AC cos 2 pi fct plus cos Kp mt. So this is given in this question. Now a little bit correction in this question. It is written as AC cos, bracket should be here, it will be 2 pi into 10 to the power 80 plus Kp mt. So this is basically given the equation of a phase modulated signal. So now, so this bracket should be here. So this should be the correct question. Okay. Now this message signal is given. This is your time axis. So this is your time axis, and time axis is given in milliseconds. And this periodic message signal would have been passed through a phase modulator, so that this phase modulated signal would have been generated. Now in this question, the maximum instantaneous frequency and the minimum instantaneous frequency has the difference of 100 kilohertz. So we have to calculate Kp. So first of all, let us write this phase modulated signal, which is AC cos 2 pi into 10 to the power 80 plus Kp mt. So this is your message signal. This is given in the problem. Now apart from that, it is also given that this maximum instantaneous frequency minus this minimum instantaneous frequency of this phase modulated signal is 100 kilohertz, and we have to calculate the value of Kp. So from here we again start from the basic, that this theta I which is given in the problem is cos 2 pi into 10 to the power 80. This is your theta it, which is 2 pi into 10 to the power 80 plus Kp mt. So whenever we will differentiate it, instantaneous angle, we will get instantaneous frequency in radians per second. So it becomes 2 pi into 10 to the power 8 plus kp dmt by dt. Now this fi as a function of t can also be written as 2 pi into 10 to the power 8 upon 2 pi plus kp upon 2 pi dmt by dt. So this fit can be written as 10 to the power 8 plus kp upon 2 pi dmt by dt. Now we have to calculate its maximum and minimum value. So we know that the maximum value of this instantaneous frequency will become 10 to the power 8 plus kp upon 2 pi dmt by dt maximum, and the minimum value will become 10 to the power 8 plus kp upon 2 pi dmt by dt minimum. So we have to calculate the minimum and maximum value of the slope. So let us try to calculate the slopes here. So you can see two sections here. One section is this, another section is this. So if I will calculate slope of this section, so you can write it as 12.5 upon this duration from here to here is 5 and this height is 12.5. So this becomes 5 into 10 to the power minus 3, and slope of this section, the height I will again consider it is from 12.5 to this minus 5, and this width is 1. So this height can be written as minus 7.5 upon 1 into 10 to the power minus 3. So from here you can say that the maximum value of the slope becomes plus 12.5 upon 5 into 10 to the power 3, or you can write it as 2.5 into 10 to the power 3. Similarly, the minimum value of the slope can be written as minus 17.5 into 10 to the power 3. So we can write this as 10 to the power 8 plus kp upon 2 pi. It becomes 2.5 into 10 to the power 3, and this can be written as minus kp upon 2 pi 17.5 into 10 to the power 3. So now we have to calculate their differences. So this fit max minus fit min. So this difference is given as, in the problem, 100 kilohertz. So this difference is mentioned as 100 kilohertz. So the difference can be calculated as kp upon 2 pi. It becomes 2.5 into 10 to the power 3 minus kp upon 2 pi 17.5 into 10 to the power 3, and it comes out to be equal to 100 kilohertz. So you can write it as kp upon 2 pi into 20 into 10 to the power 3 equal to 100 kilohertz. So from here you can calculate your kp to be equal to 100 into 10 to the power 3 into 2 pi upon 20 into 10 to the power 3. So this 10 to the power 3, 10 to the power 3 gets cancelled out, and you get kp as 10 pi radian per volt. So this question you can also proceed from the very basic. You need not have any you need not to remember any complex formula or something. You just have to proceed from the basics so that you can easily solve the question. So now let's proceed to the next question. This is the next question. So in this signal, an FM signal is given to us, which is cos 2 pi fct plus 2 pi kf, and it is being integrated from 0 to t mt dt, and the modulating signal or the message signal is given like this. Now in this question, the peak to peak frequency deviation is given as 25 kilohertz. We have to find the value of kf. So first of all, it is the expression of an FM signal, which is given as 100 cos 2 pi fct plus 2 pi kf 0 to t mt dt. So again, the bracket should have been here. There should not be any bracket. So this is the general expression of your FM signal. Now in the question it is given that peak to peak frequency deviation is given. So we know that what is peak to peak frequency deviation. The peak to peak frequency deviation means FIT max minus FIT min. So we have to calculate FIT max and FIT min for this particular case. So in this case also, you can say that this is representing your instantaneous frequency, instantaneous angle. So this instantaneous angle can be written as 2 pi fct plus 2 pi kf 0 to t mt dt. So whenever you will differentiate it, you will get 2 pi fc plus 2 pi kf mt. Now this will represent your instantaneous angular frequency. So instantaneous angular frequency in hertz can be written as fc plus kf mt. Now what will be the maximum instantaneous frequency? So the maximum instantaneous frequency becomes fc plus kf mt max. And what will be the minimum instantaneous frequency? So the minimum instantaneous frequency becomes fc plus kf mt min. So this can be written as fc plus kf mt max is given as 10. Similarly, this becomes fc minus 5 times of kf. So from here you can see that the maximum value of mt is coming out to be 10. So this will represent your mt max, and this is your minimum value of mt, so it is representing your mt min. So the difference you can calculate, this difference, which is FIT max minus FIT min, which is representing your peak to peak frequency deviation, which is given as 25 kilohertz. So this difference comes out to be 15 times of kf. So from here you can calculate kf as 25 kilohertz upon 15, or you can calculate it as 1.6 kilohertz per volt. So this is going to be your final answer for this particular question. Now let's move on to the next problem. In the next problem, a modulating signal is given, Kp is given, and the modulating signal is phase modulated. We have to calculate its instantaneous frequency at t equal to 0.5 milliseconds, and carrier frequency is given as 20 kilohertz. So this is your modulating signal, which means this is your m of t. So it becomes 5 sine 4 pi into 10 to the power 3t minus 10 pi cos 2 pi into 10 to the power 3t. So this is your message signal or modulating signal. Kp is given as 5 radian per volt, and also the carrier frequency is mentioned as 20 kilohertz. Now since this is the case of phase modulation, so what we can do, the general expression of the phase modulation becomes theta it equal to omega ct plus kp mt. we have to calculate the instantaneous frequency. So for instantaneous frequency, we will differentiate it. So it becomes omega as a function of t equal to omega ct plus kp dmt by dt, or this FIT becomes FC plus kp upon 2 pi dmt by dt. So in the problem, FC is given as 20 kilohertz. This kp is 5 radian per volt upon 2 pi. We have to calculate dmt by dt. So this is only the function of time, rest are constant. So first of all, what I will do, I will calculate this dmt by dt at the given time. The time is mentioned at 0.5 milliseconds. So at 0.5 milliseconds, we will calculate this. So the m of t which is given in the problem is 5 sine 4 pi into 10 to the power 3t minus 10 pi into cos 2 pi into 10 to the power 3t. So first of all, we will differentiate it. So whenever you will differentiate dmt by dt, you will get 5 into 4 pi into 10 to the power 3 plus 10 pi into 2 pi into 10 to the power 3 sine 2 pi into 10 to the power 3t, and the differentiation of this will become cos 4 pi into 10 to the power 3t minus 10 pi cos 2 pi into 10 to the power 3t. So you can put the value of t as 0.5 millisecond. So let me put the value of t as 0.5 milliseconds. So it becomes 4 pi into 10 to the power 3 plus 20 pi square into 10 to the power 3 into sine 2 pi into 10 to the power 3. It becomes 0.5 milliseconds. So it can be written as 0.5 into 10 to the power minus 3 into cos 4 pi into 10 to the power 3 into 0.5 into 10 to the power minus 3 minus 10 pi cos 2 pi into 10 to the power 3 into 0.5 into 10 to the power minus 3. So you can write it as 5 into 4 pi into 10 to the power 3 plus 20 pi square into 10 cube, and this can be written as this 10 power 3 10 power minus 3 gets cancelled out and it becomes sine pi, and this can be written as cos. You can write this expression as 2 pi minus 10 pi cos. This expression also becomes cos pi. So overall this expression, because of this sine pi, this overall expression becomes 0 because the value of sine pi is 0. Now we know that cos pi is equal to minus 1. So the overall expression, which becomes 5 into 4 pi into 10 to the power 3 plus 0 into cos 12 pi. We know that value of cos 12 pi is 1. So it becomes 20 pi into 10 to the power 3. So we have calculated this value, which is dmt by dt at t equal to 0.5 millisecond, and it is 20 pi into 10 to the power 3. So let me put the values here. So this FIT, which was 20 kilohertz plus 5 upon 2 pi dmt by dt. So we have to calculate the instantaneous frequency at t equal to 0.5 milliseconds, and it will become 20 kilohertz plus 5 upon 2 pi dmt by dt at t equal to 0.5 milliseconds. So you can write this as 20 kilohertz plus 5 upon 2 pi, and this dmt by dt at t equal to 0.5 millisecond becomes as 20 pi into 10 to the power 3. So this can be written as 20 pi into 10 to the power 3. So this you can write it as 20 kilohertz. This 2 pi gets cancelled out 10 times, so it becomes 50 into 10 to the power 3, or you can write it as 20k plus 50k, or this instantaneous frequency at t equal to 0.5 milliseconds comes out to be 70 kilohertz. So this was the answer to this particular problem. Now let's move on to the next question. So in this question, a message signal is given, and this message signal is first of all passed through a PM modulator, then it is passed through an FM modulator. So the output of the PM modulator is a PM signal, and output of an FM modulator is an FM signal. And we have to calculate the ratio of this Kp by Kf in radian per hertz such that the maximum phase deviation in both the cases are same. So basically it is saying that we have to keep the maximum phase deviation in the both the cases should be equal or same. So the three parts of this question are given. So in all the three parts, the message signals shape are a little bit different. So I'll start this one by one. So first of all, let me consider the first message signal. So this is your first message signal, which has a shape like this. So this is the shape of the message signal. This is time axis 0, 1, 2, 3. This value becomes 4. This value becomes -4. Now this message signal is being passed through the FM modulator as well as PM modulator, and the purpose is that the maximum phase deviation in both the cases must be same. So first of all, let me talk about this calculation, that you have to calculate Kp by Kf in radian per hertz. Now we know that Kp has only one unit, which is radian per volt. So Kp unit is radian per volt. So this Kp unit can be written as radian per volt. But Kf has two units. One unit of Kf is radian per volt second, and another unit of Kf is radian per hertz. Volt per hertz. So another unit of Kf becomes hertz per volt. So basically you have to calculate Kp by Kf in radian per hertz. So Kp will always be in radian per volt. Kf can have two options. It can be radian per volt second, or it can be hertz per volt. So very clearly you can see from here, if I want my ratio to be radian per hertz, then Kp must be in radian per volt, which will always be, but Kf must be in hertz per volt. So first of all, the first information that we extracted from here is that the unit of Kp is radian per volt in this case, and unit of Kf is hertz per volt. Now we know that we have to keep the maximum phase deviation of FM, and this should be equal to maximum phase deviation of PM. So what we can do, first of all, let me consider the PM. So for PM we know that we have only one general expression, which is theta IT equal to omega CT plus Kp mt. So this theta IT can be written as omega CT plus delta phi t. So this delta phi t becomes Kp mt, and maximum phase deviation becomes Kp mod of mt max. Now you have to find out the maximum value of message signal. So you can say that the empty max is +4 and empty min is also -4. So after taking modulus, both values will become same. So this mod of empty max can be written as 4. So I can write it as delta phi t max equal to 4 kp. This is equation 1. Now let us come to the FM. So we know that in case of FM we have two standard expressions. So based upon the value of kf we choose any one of them. So if I might consider my kf to be in hertz per volt, so this FIT can be written as FC plus kf mt. Now we are interested in the phase deviation. So first of all I should calculate omega it. So this omega it becomes omega c plus 2 pi kf mt. Now if I will integrate it from -infinity to t omega it dt, and I will integrate it -infinity to t omega c dt -infinity to t 2 pi kf mt dt. So this becomes theta it, this becomes your omega ct, and this becomes 2 pi kf -infinity to t mt dt. So if you will compare this theta it with omega ct plus delta phi t, so from here this delta phi t can be written as 2 pi kf -infinite to t mt dt. So this delta phi t mod max becomes 2 pi kf, and we have to calculate, first of all we should take its mod, then we have to calculate its maximum value. So we know how to calculate this particular expression. For this we were making table from the AM also. So in case of AM also we have to calculate the maximum value of the magnitude of the integrated signal. So again this is your message signal, this is m of t versus t, and it becomes constant 2 3. So this is 0 1 2 3, it becomes 4, it becomes -4. So we will make a table up to, then we will calculate -infinite to t mt dt, which is your area, then we will calculate magnitude of area. Now here we have different transition points. So transition point, one transition point is 0, then from 0 to 1 the graph's nature is same, then another transition point is 1 where graph shape is changing, then another transition point is 2, and the last transition point is 3. So we have to calculate the value of this integration, and basically we have to calculate its modulus. So if I consider up to t equal to 0, then area will become 0, mod will also become 0. Now if I consider up to t equal to 1, then the area becomes half base into height. So this is half base into height, it becomes 2, magnitude also becomes 2. So basically you have to calculate area up to t equal to 1, which means this previous areas will also get added up. Now we have to calculate area up to 2, which means you have to start from -infinity and you have to reach till 2. So graph from -infinity to 0 does not exist, which means now in this case you have to calculate this area, which is a1 plus a2. So if I can call it as a1, so you have to calculate this a1 plus a2, so it will become 2 plus 4 or 6, and the mod also becomes 6, and finally you have to calculate area up to t equal to 3. So in this case this area will become a1 plus a2, and this area is a3, so I'll write it at -a3 because this area will be some negative in value. So you can calculate 6 minus, and this area becomes 4, so this value becomes 2, modulus value becomes 2. So from here you can say that if I take the magnitude of this expression. So after taking the magnitude, it becomes 0.262. And if I want to calculate the maximum value, so the maximum value comes out to be 6. So this method we already discussed in the AM problems, that how to calculate the maximum value of an integrated signal, or how to calculate the maximum value of modulus of that integrated signal. So we need not to draw the graph every time. We can simply make this table, and in this table, this up to means we have to take the transition points or the transition instances, and we have to calculate the area up to transition instances, and after that you can calculate your desired value. So now if I'll put this value as 6 here, so it becomes 2 pi kf into 6. So according to the question, this mod of delta phi t max of PM should be equal to mod of delta phi t max of FM. So in case of PM, it comes out to be 4 kp. In case of FM, we calculated it as 2 pi kf into 6. So you can see it here. This is your 2 pi kf into 6. So upon solving, this kp by kf comes out to be 3 pi radian per hertz. So this unit is also very much important. Based upon the unit only, we can calculate this answer. Now, let us try to calculate the second part of this question. B part. In case of B part also, you can see that your message signal is now changed. So in the B part, the message signal is given like this. So it is from -2 to 2, 0 to 2, 2 to 8, and 8 to 10. So this is your required message signal. Now, first of all, let me draw the message signal in this case. So if you will draw the message signal, so the message signal might look like this. And from -infinity up to this point, it remains 0. So it becomes 0, 2, 8, 10. This point becomes 2. This point becomes -2. In this case also, we have to make the delta phi t max of PM should be equal to delta phi t max of FM. So for PM, we have already calculated, it was Kp mod of empty max, and for this it becomes 2 pi kf -infinity to t empty dt max. So these two values we have already calculated. So we again have to calculate the value of this Kp by kf in radian per hertz. So these two values we have already calculated in the last part of this problem. Now in this problem, we have to find out this mod of empty max and this -infinity to t mod of integration of empty dt. So you can clearly see from here that if you will take the magnitude, then the maximum value of the magnitude comes out to be 2. So it becomes 2 kp 2 pi kf -infinite to t empty dt max. So we have to find the value where this particular integration becomes maximum. So again, we will follow the same procedure. This is your message signal. And this is your 0, 2, 8, 10. It becomes 2, -2. So this is your A1, A2, A3. Now we have already identified the transition points. So the transition points becomes 0, 2, 8, 10, where the definition of the function changes. So in order to obtain the maximum value, we will use the following table. So this will represent the time, this A will represent the area up to that point. So this is empty dt, and finally it becomes magnitude of A. So up to t equal to 0, the area becomes 0 and the magnitude also becomes 0. So up to t equal to 2, this area becomes A1, which is equal to 4, and magnitude also becomes 4. Now up to t equal to 8, if I have to calculate the area, so it will become A1 minus A2, or you can calculate 4 minus 12 minus 8, but the modulus value will become plus 8. And up to t equal to 10, you have to calculate A1 minus A2 plus A3, so it will become minus A plus 4 or minus 4. So from here you can see that this will be minus 4 and the modulus will become plus 4. So you can see that this minus infinity to t empty dt, if I will take its mod, so the maximum value comes out to be, this will be 0, 4, 8, 4, and the maximum value becomes 8. So I'll put this value here. So it becomes 2 kp equal to 2 pi kf, and this expression becomes your 8. So from here kp by kf comes out to be, this 2 gets cancelled out, and it again gives the result in radian per hertz. Now let us try to solve the C parts also for this problem. In the C part also we have to calculate this kp by kf in radian per hertz. So this is the same problem, that this kp will be in radian per volt and kf has to be in hertz per volt. So in this case also you have to equate the delta phi t max, the maximum phase deviation, which is mod of delta phi t max of Pm equal to the mod of delta phi t max of Fm. So this becomes your Kp mod of empty max, and this becomes again your 2 pi Kf minus infinity to t empty dt max. So this we have already proved in the part 1. Now you have to calculate mod empty max and magnitude of area's maximum value. So first of all, let us see what is your m of t in this case. So let us see what is your m of t in this case. The m of t which is given in this case is a square wave. This is the square wave. So it becomes 0, 2, 4, 6, 8, 2 minus 2. Now what you can do, first of all, you can calculate the mod of empty max value, and it is coming out to be 2. Now this becomes your A1, A2, A3, A4 and so on, and the transition points becomes t equal to 0, t equal to 2, t equal to 4, 6, 8 and so on. So here you can make a table up to, then this area minus infinity to t empty dt, which is A, and finally mod A. So you have to calculate value up to t equal to 0, it becomes 0, 0. Area up to t equal to 2, it becomes A1, so we can call it as 4, and magnitude also becomes 4. Up to t equal to 4, these two areas are equal and opposite, so this becomes A1 minus A2 and it becomes your 0. So the magnitude also becomes 0. Similarly at t equal to 6, you have to calculate A1 minus A2 plus A3 and it comes out to be 4 again and 4. So you can see that this magnitude is repeating between 0, 4, 0, 4. And if I have to calculate the maximum value after taking the modulus, so whenever you have taken the modulus, so the maximum value comes out to be 4. So this empty max becomes 2 and integration of empty max becomes 4. So let me put these values here. So this becomes your 2 and it becomes 2 pi kf into 4. So from here you can write your kp by kf should be 4 pi radian per hertz. So that is it in this lecture, and more number of problems we will solve in the next lecture. Thank you.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is Vishal Gate. Write my name and attach Gate to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code Vishalgate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription, cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now, how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription. तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.